Hi there, this is Dr. John, your physics and math professor, and I'm coming to you with another transformations example. Remember, we do these transformations in this order: stretch, reflect, translate. If sort helps you to remember it, there's no O in this, of course. S for stretch, R for reflect, T for translate. Often we can do the stretch and the reflect together, but we have to do the translate afterwards. So here I've given you an example here. This is a square root function, and what you want to do is you want to start off by looking at the root function, or sorry about the pun. You want to start off by looking at the function that this is all based upon. So this is a square root. It's got a modification in here, some sort of stretch factor, some sort of translate factor, and another stretch factor, and another translate factor here. But the core underlying function here is the root of x. So I drew that out for us. That's sort of like the way that we start. We start with this function, and then we see how these different numbers modify that function. But to find out how these things modify it, we're going to have to break this apart. This is pretty straightforward. This is pretty, but this inside here is convoluted. We're going to have to pull it apart. So I'm going to write this out here again here. It's minus 2x plus 4. This is all in brackets. I just put the brackets in there just to make clear that all of this is inside the square root function. So we want to break this apart. What we want always is to have something like x minus 3 or x plus pi. So we want to have these separate like this so that we understand clearly that it's a translation to the right by 3 or to the left by pi. This has to be very clear. Just x and just the number, or just some other number like pi. And then let's say there's a stretch factor in front of it or a reflection factor in front of it. That's fine, but we want to have it pulled apart like this. So take a look at this here. This obviously, we can't really operate with it like this because we don't know exactly what part of this is stretch, what part of this is translate. So we want to deconvolute it. Let's start by doing that here. Well, obviously we want to get the x by itself, so we're going to take out a minus 2. So if we take out a minus 2, put lots of brackets, then this is going to be x. So this here takes care of this term. What is this term? Well, let's try this. Plus 2. This is a 4, this is a 2. This times this is minus, whoops, that can't be a plus, so that's going to have to be a minus. Double negative here. So minus 2 gives me a, minus 2 times minus 2 gives me a plus 4. So all of this is the same thing as inside the square root. Of course, we want to keep the square root around everything. It includes all of this. So now we have this part deconvoluted. We still have a minus 1/2 in the front. We have a plus 1 over here. So I'm going to rewrite all of this up here with this broken apart, with all of these factors included, and see what we need to do first, what we need to do second. So here I have rewritten this. I've taken this here, rewritten it up here instead of this, put the minus 1/2 and the plus 1 up there like that. I can erase this now. Now let's take a look at this and see what we need to do first. So here we have, this stuff is inside the function. The function is the square root function. These two things are outside the function. The things that are inside the function that act directly on x, the 2 acts directly on x, and this 2 acts directly on x. All of those things impact the x, what happens to the x points. So this here is going to be a stretch. What kind of a stretch though? Obviously it's a negative, which means it's going to be some sort of reflection. It's going to be some sort of reflection this way because it's going to be a negative stretch in the x. But remember, we flip this because it's right inside there. So this is going to be multiplied by negative 1/2. Whatever the x value is, we're going to multiply it by negative 1/2. And then after that, we're going to add 2. When they're directly inside like this, we do the opposite. We still use the minus sign, but we flip this. We make it a half, and we make this, instead of minus, we make this plus. So we've done that. We've worked on that in a number of videos where we just did individual things, but now we're doing this all together. So hopefully you can follow this. So this is what happens to any x points here. The 0, the 1, the 4, this is what happens to the x points. Now what happens to the y points? Well, for the y points, we have this over here. This is a little bit more straightforward. The y points, the first thing that we're going to do to the y point is stretch it. How much are we going to stretch it? By minus 1/2. Now notice that this is a minus 1/2 stretch, and this is a minus 1/2 stretch, but this one is directly attached to the x right inside here, and these are not directly attached to the y. Remember, we have y on this side. If we took this to the other side and attached it to the y, it would be minus 2y. That would have a minus 2y, which would be just like this, minus 2x. So it would be analogous then. If we move this to the other side, it would be a -1 as well. But it's on this side, everything's on this side because that's how we tend to write these equations. So it's a little bit confusing. You just have to separate the stuff that's directly tied to the x to the stuff that is really tied to the y, but we put it on this side. So for the y, we multiply it by -1/2, that's this one right here, and then we're going to add 1. So this is what we're going to do to the x, this is what we're going to do to the y. So I don't need all of this anymore. Maybe I'll take this and I'll just rewrite it up here so we have it as a reference. And then I'm going to make a little chart so that we can look at different points here and see how we will transform them to the new points. Give me a second to do that. I'm back now here. I have taken this and rewritten this up here where I've just deconvoluted this inside here. Otherwise, this blue one is the same as the black one here. And here was the original things that I had. So the original x and y values are x and root of x. X is the independent variable, y is the dependent variable. And so this is the original function. Then here's the modified function. -1/2 times x plus 2 -1/2 y plus 1, just right over here. So I can erase this, make myself this little chart here, like this. So here's going down, and we're going to have a couple of points. And since this is a smooth function, we only need a few points because we know the function afterwards is going to be smooth as well, whatever it looks like. So I've got 3 points right here. This one is 0, 0. This is the x value. This is the root of x. This one is 1, 1. This is the x value, and that's root of x. And this one is 4, 2. We could have an infinite number of points, whatever points we wanted to. We can't have any points over here because this function, the root of x, is not defined when x is less than 0. So the domain is x being greater than 0, and the range is y being greater than or equal to 0, and the range is y being greater than or equal to 0 as well. So here we have 3 points. 3 points were enough for this. 3 points should be enough for the modified one. So let's take a look at these points here. These are the original points, x and root of x, and then here's the modified points. I'm going to do them in the color code. So we'll start off with the blue ones, which is the new x values. 0 times this is 0, plus 2 is 2. 1 times -1/2 is -1/2, plus 2 is 1.5. 4 times 2 is 1/2 is 2, minus 2, plus that is 0. Now for the y's, I'm going to use a different color. And it's very similar. It would be this times this is 0, add 1, there you go. This times this is -1/2, add 1, and we get what? 1/2. This times this is -1, and we get 0. So here we have a couple of points. Let's take these points and plot them over here. So we'll start off with 2, 1. So this is 2, 1. So right over here, that's that point. This point is 1.5, 1/2. 1.5, 1/2. There somewhere. This one is 0, 0. There, like that. And we could have a couple of more points. Now this point over here represents this first point here. So you can notice it's going to do something like this. Because it's going to be flipped both in the x, this way, and in the y, this way. And it's going to be shifted. So here's the up shift by 1. You can see that. It's shifted up by 1. It's also shifted to the right by 2. You can see that right here. So this purple one here is shifted to the right by 2, and it's shifted up by 2. So you can sort of see that in the equations here. If we had another point, maybe we could just use one more point and see what happens here. What would be the next one that has a nice square root? Well, that would be 9. The square root of 9 is 3. So -1/2 times 9 is -4.5. Add 2. So -4.5. Add 2. We're going to get -2.5. Don't need this. And then this one here times this is -1.5. Add 1. We're going to get -1/2. Whoops, this one should be this color here. -1/2. So let's take a look at it, see if we can plot this one as well. So this is -2.5 for the x, 1, 2, so it's right here. And this is -1/2. So it's going to be, I exaggerated this a little bit, so it's going to be somewhere up there. And that's this point way over here. It's a little bit off my scale, right around over here. So here we have the original and we have the modified. This would be pretty difficult to do if you tried to do it just by doing the stretch first, and then doing the reflection next, and then doing the translating and doing it all manually. But doing it mathematically this way is an awful lot easier. So I hope that helps. If it did, like and subscribe, and check out my next video. I'll talk to you soon. Bye-bye.